See here. Welcome, folks, to another Containers from the Couch. Today is Tuesday, July 22nd. We'll give it a minute or two for people to join. We have a special event today with Dagger folks joining me. So I'll bring Jeremy on board. I'll bring Kyle on board. So everyone should say hi to them. Let me check how the stream is going. If you are just joining, put a message. Oh, we already have people joining. So
Oh, nice.
We have Robbie saying hello from San Diego. So it's early over there. So good. He got up early to see us. I think it's about
noon on the West Coast.
Yeah, they're having lunch. So they're picking up their lunch, their coffee, and going back to the desk to sit and eat and enjoy some cool tech that we have to show. So let's do some intros. You have seen the show before. I'm Carlos Santana. I'm a solutions architect for AWS. And in this YouTube channel, I cover all things surrounding EKS, Kubernetes, and the ecosystem of DevOps for containers. And I'm super glad to invite some folks that are very good friends. We have hang out in different KubeCons. Jeremy and Kyle, welcome. Welcome, hey. Jeremy, Kyle.
Thanks, Carlos.
Introduce yourself, Jeremy.
Yeah. Thanks for having us, Carlos. Super excited to be here with you today. I'm Jeremy. I'm over at Dagger ecosystem team. We work a lot with partners and users on figuring out how to use all this cool tech these days, including a lot of Dagger. And excited to share some of that with you today.
Great. Where are you joining from?
Oh, I'm over in Portland, Oregon, so on the west coast of the United States. And I might know some of you all from past companies. I was at GitHub before and some other places. So I've been around for a while, but yeah, excited to be here today.
Great. How about Kyle? Welcome, Kyle.
Yo, yeah, I'm Kyle. You might recognize me from Dagger's YouTube or from any of these DevOps conferences that we've been at. I am located in Indianapolis, and let's see, I've been kind of in and around DevOps, release engineering, builds, tests, all that stuff for about 15 years at all kinds of different organizations. And yeah, I really like building on kind of the next generation of this stuff at Dagger.
Yeah, excited. I remember when I met you, now I'm trying to remember, in Toronto, there was a conference.
Yes.
I met you there. We were having lunch and you showed me Dagger CLI and I was super excited. And then I was asking you, like, how did you make that CLI look like that? Like, we have been built a lot of CLIs in different companies. I have built a lot of CLIs in different companies, open source and not open source. And I was really asking, like, how did you make that CLI like that? I remember you had your co-worker with you. And it's like, oh, that guy did it. And we had a fun conversation around that. So, and that was years ago. So I'm the stuff you showed me previously, it's super cool on how to use Dagger, and the user experience, right, of that at that time was novel. So today you're going to show us some cool stuff on how to build applications and then get them launched into EKS. So let's start with that. On launching things, I see a rocket in Dagger's logo. What is that rocket about? I think it's a rocket. I don't know. It could be a guitar thing, right, to play the guitar.
Yeah,
so it could be one of two.
Yeah, it's up to, I mean, it's really in the eye of the beholder, Carlos. So like, whatever you're feeling today, I've heard some different interpretations, but yeah, I think rocket's a great one for today. I think we're trying to blast off. We're going to, give some folks their first introduction to Dagger. And then we're also going to touch on container use, which is this really cool agentic like application of Dagger. So like, let's dive in and just give everybody a little level set so we're on the same page. For folks that maybe haven't run into Dagger before, the founders of Dagger, also the founders of Docker, you might know, Docker certainly if you're watching a Kubernetes channel, hanging out with Carlos. But think about Dagger as a next generation kind of container and workflow engine and platform. So think about it for software engineering workflows of all kinds. So it could be for CI workflows, dev, test, agentic workflows, agentic CI, which is kind of a new thing that we're seeing a lot of interest in. And the way the Dagger platform is put together is it's the central Dagger engine. That Dagger CLI that Carlos saw and liked, it talks to that Dagger engine as well. And there's this kind of uniform API across the CLI. You can access it. You can also get to it through code SDKs. So we've got Go SDK, TypeScript, Python, PHP, Java, a bunch of SDKs are available there. And you can work with all of these core objects. Like you can build containers, and you can work with directories and files and getting things from the web or from Git and all sorts of things, secrets, of course. And then there's also core types around LLMs and environments for LLMs to get their inputs and have their outputs come in and out. So, AI baked in, and some of this content you create, you can also share really easily. So you can compose all of these different things together. You can build things, you can run them on the Dagger platform, and you can also share them via the Daggerverse. And as you're running all of these different workflows, which you'll see as Kyle takes us through, you can also emit all of the telemetry from them up to Dagger Cloud. And the really cool thing, kind of secret sauce thing you might have heard before, is that Dagger runs the same everywhere. So whether you're running it in a CI like GitHub Actions or Jenkins or AWS Code Build or whatever, or if you're running it locally right on your laptop, it runs exactly the same. So that's like a really unique benefit that you may have heard of, and it makes things a lot easier, especially if you're
portable, right? Like if you are like a DevOps or platform engineer and building pipelines with Code Build or GitHub Actions or GitLab, the installation, right, it's not an RPM. I'm guessing it's just a simple binary.
Right. So the CLI is a simple binary, and the engine just is distributed as an OCI image. So you could run that Dagger engine anywhere. Run it on your laptop, say with Docker or Finch or whatever. Or you could also run that in Kubernetes. Say run on EKS, and we've done a lot of that, and we've got Helm chart for that as well. So yeah, that's a great way to run Dagger. And then this is some Dagger code for folks that haven't seen that before. Remember, there's different SDKs. This is a TypeScript example, but you could run in your favorite language, and all the languages are mix and match. So you can borrow a Python module that has some useful functions from your friends over there, or share this TypeScript one with folks that write Go all day, and you can all use each other's functions. Here's an example of a build function that's at the end of the day going to be taking in a directory of source code and returning a container, a built container, that you could then publish, or you could run it, or get a terminal inside it, or run it as a service, whatever you want to do. And you can just get the flavor of that API that's being invoked here. We're execing things, we're extracting a directory, we're moving that directory into a new container, like a multi-stage build. And once you've done that, you've just extended that core API from those core functions that we had. Now you've got this new build function. And this could be something that you could provide to all the devs in your organization if you're a platform engineer, and really build up an internal platform that's built on code all the way down.
And Jeremy and Kyle, I think we need to stop here for a little bit, right? Like platform engineers or people, DevOps engineers that are working with pipelines, basically, I think they, for many years, have been writing shell scripts. So people see this and they say, this is code. Like I can run this in a shell script. I can write a shell script that cats a Docker file and runs a shell script that npm run, and then some flags, and then Docker with some flags on dash volume, and then the image, right? But that shell script is something that then it becomes something that is fragile, I would think, right? That you need to have some humans, then you have to write another bash script to test the bash script, right? Because who's testing and validating this, right? When we use code like this, it could be QLang, it could be Go, it could be Python, it could be JavaScript. It's something that is strong types, right? That you if this thing have a compile error, if you're missing a dot, you're missing a semicolon, right? It doesn't work. Like it doesn't ship. You can fix that. You can quickly see that.
Exactly.
And the maintainability, right, of this is code. And with today's tools, right, with IDEs, there's a lot of things that you can start with, but like doing a dot and autocomplete, right, is code. Like there's IntelliSense code servers, like for the last, 7 years. And lately, like people don't talk about them, but lately, like, oh, I have a Python code server, I have a DSL code server. So I'm guessing that Dagger has a code server that you say dot, and it knows how to autocomplete this small function that at the end of this is a pipeline by code. But if it doesn't compile, it doesn't run. A bash script, there's no bash script compiled, right? I don't know. That's my point of view. I want to hear from you. What you're in the field.
Yeah, I mean, to me, that's exactly what we see, and one of the big reasons why we choose code as the core way of writing Dagger, and these different SDKs. Right at the end of the day, if you want, it's the kind of the magic under the hood. It's all a GraphQL API, so it's all one API, and these different SDKs let you write in your favorite language and use any libraries you have from that ecosystem together, but what we do to normalize it and make sure everything actually works, we create a runtime container that allows, say, this TypeScript code to all run in a TypeScript environment, or Go code to run in a Go environment. But you can compose all of those different things together, multi-language. And just like you said, Carlos, it is just code. So you can do things like you get LSPs that work. So you can actually get IntelliSense and things like that. You can actually, syntax checking, strong type checking. Of course, it's just code in Git. So again, there's not like some proprietary formats or anything like that. Super easy to version, to share, to test as well. And some of the advantages of using real code.
And also the misconception, people see something like this or similar things like CDKs or things that you write in code, is that you're throwing away your GitHub action or your GitHub or your Jenkins. I don't think so, right? You're making those pipelines better by taking all these in the middle shell script. I used to do Tecton a lot and work.
Yes.
So basically, people say you're going to run this natively. You're going to run bash script natively. It's just shell scripts that are injected in the middle of a spec of a CR of a CRD.
Right.
Jenkins still is a snippet of code of which bash if statements and checking variables and composing that thing that once it works, nobody wants to touch it, right? Don't want to enhance it, don't want to refactor it. When we're dealing with code, it's code that's those pipelines run that code, right? That more strong type code. You're showing something. I guess you're showing an example here.
Yeah, no, exactly. No, I mean, and just like you say, you get all the advantage of something like Golang and the strong typing, for example, but you can also use anything you have. So if you already have a snippet of bash that it does exactly what you need, you can insert that in your Dagger pipeline, just have that get executed as one of the steps, no problem. So get reuse that way, but then all the safety of the rest of it. Additionally, in all the places that you're used to running a shell script today, say in GitHub Actions and a little run block, or in a Jenkins, shell kind of step, that's the perfect place to actually invoke your Dagger function. So remember that function was called build. This would be how we would actually use this in the CI context. You just say Dagger call build, call the build function. The same thing you do from any CI or on your actual CLI of your laptop. As a developer, you can also call Dagger call build. So again, you're getting in this situation where you don't have to have developers saying, "Oh man, I can't get my laptop build to match what the CI build is because I'm using my own tooling that I like, and they use different tooling, the central platform." Here, everybody's on the same page, and you get something that's always going to work consistently.
And you mentioned Go, but I'm guessing that you have multiple languages. Lately, I'm using a lot of Python because of the tools that I use I'm using a lot of tools with AI Agentic, and Python is one. The canonical example, but all these tools work with other language, but I think they started with Python. That once you use Python, or your language, right? Could be TypeScript, it could be JavaScript, Python. And you are a developer, you have that folder that is called test or N2S. So you run npm test or you run PyTest. You don't want to run the PyTest that runs the shell script that runs right? So if you have your IDE and you have your agentic copilot, right, your helper, it could be Amazon Q, it could be Klein, helping you on with that code that is your business logic, and you're a small shop, help me with the test logic, right, which is written in the same language that I have dealt in the morning. In the afternoon, I don't have to switch context switch.
Exactly. I mean, that's the idea. Whatever you're using to write your code, write your tests, now you can write your CI or any of your other dev workflows with. It keeps you in that same language. And then again, like you say, you're not locking yourself into one language, because you could build a platform now that is multi-language, because since all calling the same API under the hood, it means that I can import your Python module into what I'm writing in TypeScript, and then what I've created can be shared with someone else running Java or Golang or whatever. So yeah, it's all about sharing and bringing these things together, and because containers are really baked in. That's what we do at Dagger is create these containerized environments for running these workflows. It was natural, as we started getting into more of the world of agents that's really been happening this year. We saw both with a core LLM type that we have in Dagger. You have the ability to use LLMs right in your workflows. So if you're already doing CI workflows and you want to have some agentic CI where you want to start doing some agentic code reviews and things like that, you can do that. But we also found that some people, even kind of before that, maybe they weren't building the whole platform yet, but they were experimenting with these coding agents. They were experimenting with Amazon Q CLI. They were experimenting with Copilot and Claude Code and all these different things, and they're playing with these things, and we're playing with MCP servers, right? It's another thing this year that's been everywhere. And they started running into these problems where everyone was trying to run these coding agents in a YOLO mode, right? You're running it like right on your laptop. This thing is using tools, and it's like chopping up files right there on your machine, and like adding things and and deleting things. And some people really just like leaned in on that and said, wow, this is super cool. Other people, including some companies, were like, no, that's illegal. You can't use these agents. They're too dangerous. And so there's been a lot of people have been trying to create different services for sandboxes for our agents, our AI agents to all operate in. Well, it turned out, since Dagger already provided this really great facility, this API for creating containers and giving access to those containers as services or through terminal access, etc. It wasn't that big of a stretch for us to create a new open source project that we open sourced just at the last AI Engineer World Fair in San Francisco. And we called it container use, kind of along the lines of things like, browser use and computer use. This allowed agents to have containers, containerized environments, sandboxes they could use. And that meant for all of us is that we could run agents in parallel, sandboxed on our machines or anywhere, in a way that allows us to do multiple experiments in parallel without thrashing everything on your machine, all using the power of Dagger containers, plus things like Git work trees that are able to kind of keep separate versions of a Git, separate kind of Git branches, all based in the same place that could then be resolved later. And this is what container use is. It allows us to offer that. And so a lot of what we show today will involve some container use, but kind of the cool thing for this audience is very easy to use with things like Amazon Q and Kiro and others, and we've got instructions for all of that. But yeah, I mean, this is like, Carlos, this is another kind of an offshoot of the sorts of things that we've been doing because we were working with Dagger in containerized environments, and we were also working a lot with agents. This container use thing just kind of popped out naturally.
Yeah, I think this shows Dagger customer obsessed, right? With their customers and their developers. So they're not just showing you like developers need CI/CD, this we give them CI/CD. I think you're going beyond that and listening to customers, these developers that like what are they working on the IDE, right? When they developing locally, like that fast loop iteration, and then making it safe in this container use. I'm glad that we're talking about this today, and we didn't premeditate it, but I'm going to show something that happened yesterday. Let me see if I can,
go for
share it here. So yesterday, there was a popular npm package, ESLint config. So if you are like in the JavaScript, TypeScript, but this could happen to any registry, PyPy, npm, because these type of things that can happen, right? You can download a package that you can trust the developer that put that package there, but maybe we don't trust how his computer got hacked, right? and they got access to the token, and they start like publishing malicious version of this npm packages that get 30 million downloads per week. So if you are using one of these npm packages, go ahead, run, stop now for a few seconds, run, do npm update force, remove that package.lock or use package.lock and come back. But this is an example what I wanted to show of very quickly on the value of this, because a lot of your developers that you're mentioning is they start using agentic co-pilots, right? Helpers. But they come along with the plugins. The plugins are MCP servers that are like a Python package, or usually it's an npm package, or it could be a container, but it runs on your laptop with access to all your files, including your secrets, your keychain, stuff that is not protected, but it should not be public available. And having the ability to have a container, right, where I can have like my Docker, my Python code launch into a container use that only has like my source code, right, and Python environment, and I have another in parallel, which I have my infrastructure in Terraform folder, the Terraform code with a container that has Terraform CLI, and the agent is using MCP for Terraform, and then the other one is using MCP for the Python code, my business logic, right? They can both run in parallel using something like Git tree. And Kyle, I think, is going to show something cool about Git work trees. If you don't know what that is, it's an old technology, but a lot of people, I think, we continue to start learning about it. Right, Kyle?
Yeah, exactly. Yeah, and if everyone's ready, we can kick off the demo now, I think.
Let's do it.
Sweet. So I have an EKS cluster, and it's called Containers from the Couch 2. And it's called number 2 because we're actually on Containers from the Couch like 2 years ago, showing some other cool stuff. Dagger looked totally different back then, but here we are today with some more cool stuff. And so here's my cluster. I'm running the classic Kubernetes example guest book, and so here it is. This is my production guest book. And so what we want to do with container use and Dagger and all these tools is to kind of replicate this flow where, you know, I've got the main version of my app, and someone comes to me and says, "Hey, this looks super boring. Give me some options for how it can
that
work
yellow,
better."
that gold chain look.
Exactly. It's just not it
from
you
the
know,
80s, right? Yeah.
the mustard color. We're not impressing anyone with this site today. So they say, make it better. And for me, I'm not a great UX designer, but I can use things like work trees and container use and agents to maybe produce a few different options, and we can look at those options and figure out what the site should look like. And so with this flow, you know, I'm going to have some agents running on my machine, and they're going to be working on different versions of the app. And the only way that they're not going to collide with each other on the changes they're making to the code is to actually be in different Git work trees. And so that's a baked in part of how container use works. So let's just go and look at it in action real quick. So over here in my terminal, I have my local checkout of the app, and I'm on a branch, and this is where we're gonna make the changes and check it out. So first, I'm going to use Amazon Q as the agent, and we're going to use it with container use. And so the first thing I want to do is actually enable container use for Q. And so if you're like into writing JSON files by hand, you can go do that, or you can just say container use config agent. And so we're going to configure the agent we want to use for this project. And so we've got a really nice colorful UI here where we can choose which agent we're working on. Literally any agent that supports MCP should work with container use. These are kind of the baked in ones we have right now that we can automatically generate the configuration for. So I'm going to select.
And we
Amazon
knew
Key
that the CLI is important for you, Carlos. So like,
yes,
you know, Kyle had to make it extra pretty this time for number 2. You know?
Yes.
Yeah, it's got to look good all the way. And so when I ran that, it actually created this .AmazonQ directory, which is where Amazon Q likes to have its configuration stored. So if I look at what we put in there, in this folder, we have an mcp.json and the rules file. So let's look at those. In the MCP JSON, we created this file where we say, here's our MCP servers, container use, and here's the arguments for that. We also created this rules file. container use. And so this is basically just like adding to the Amazon Q rules that we're accumulating as we're developing with this tool to say, hey, agent, this is how you should use container use as you're developing things. Because it kind of interacts with, or it overlaps a bit with some of the built-in tools. We want to say, hey, make sure when we're doing work, we're doing it with container use so that's always in this isolated environment. And if I were to mess this up, let's say we had an update for container use, and I say, do this file, and I yoink that out of there, and look at it again. If I go reconfigure, if you don't want to jump into the cool UI, you can also just put your agent.
Okay, so this is something that platform engineers can like give to their developers, right, in their organizations, like, and Dagger is very, they can customize it however they want, and like these are the rules. We can say rules, we can say guardrails, right? That we want to give Amazon Q as a system prompt, or helping with that context of like, yeah, you want me to do work, but what are my boundaries, right? Or how is I should be dealing with how when I work on this project, on this folder.
Yeah, the term rules is held fairly loosely because it is really just a prompt at the end of the day that can be broken. But we're telling the agents these are some extra things to help you do your work.
Yeah, and this is something to maybe for people to learn, that if you're watching, right, and you tell your Amazon QCLI or your Copilot, your agent, like to do this, and you have high expectations, and it doesn't actually do the things that the way you like it, you have to give it some hint or influence these agents, and this is like context, right? Like when you create a file, like have an end of file. I like those, like those rules that we usually typically have in LinkedIn. You can have that here, but also in terms of processing, like we're working with this GitHub repo. We just the branch usually main or mainline. Where's the upstream? I like my PRs to be open like this. What is the? I have 3 clusters available. Maybe you put in clusters here. When I'm working locally, always use ECAS cluster number 2, right?
Yep.
Think about it this way. Like if I walk out my front door right now and grab the person walking their dog over there and sit them at my desk, they're not going to be able to do my job. They have all the tools I have access to right now, but without some extra guidance, they can't just sit down in front of the tools and solve the same problems that I can sitting in front of the same tools, right? You need context.
Yep.
Yeah, so we've given Amazon Q this context. Let's boot it up. I've run QChat, trust all tools. I was able to run trust all tools because, again, with container use, we're sandboxing the agent. So it's not just running the commands in an isolated container, but it's also doing its work in an isolated Git work tree. So if I'm in Amazon Q and I say /tools, we see container use here because we ran that configuration, and we have all the tools, and those are all the things you can do with container use. The agent's going to figure it out because all these have little instructions on how to use them, basically. And if I say /model, we can pick a model to use today. Let's pick 3.5. Because based on my testing, that's the happiest one to use at the moment.
Cool.
And so let's make some changes. So we said we wanted some cool modern themes for that guestbook app. Let's say make the guestbook website have a really cool space theme.
Ooh,
rockets. So it's going to think about it.
We're rocking rockets, right? We started
exactly.
The podcast with rockets. Let's finish with rockets.
And hopefully it's going to turn out really cool. Sometimes you never know, but we can see it's calling our tools. So it created an environment with container use, and we'll look at what that looks like in a second. But it's going to go through, and then in that environment, start reading the files, and then probably writing the files. So while that's going,
I was going to say this is a great use case if you have a company or partner that is building educational tools, right? That you're writing tutorials or website to teach, right? You can have like students go through this build, use Dagger, use container use, and save sandboxes to give to the 15 students and give a workshop, right? It's a safe environment where you are using Amazon Q.
Yeah, there's no risk at breaking your computer here or deleting all your files. It's all isolated. But also that means, if I'm trying to optimize my own time, I can have some agents in the background on my machine working on all these little tasks while I am in this work tree here on my branch, and it's not being modified, right? It doesn't have any of those changes being made. But if I look at,
I know. So you made the agent super smart to say git stash and git pub and git stash and git pub and git stash.
Oh, no.
That's how everybody does it. No,
Right.
Exactly. So we've put it in a box with a work tree. So it's actually, it has a proper place to do the work without any weird hacks. And we can watch what it's doing here. But I can also start another session to say, all right, we've got this working on the space theme. We want to, while that's working, it might be almost done, so we have to hurry up here. We say qchat -- trust all tools again, and let's once again change that model to something
put in the
small,
link
and
there
let's say
to
make.
git work tree so people learn about.
Oh yeah, perfect. Yeah, work trees are super cool. Whether or not you're using container use, they're a great tool for doing this kind of isolation. Website have a cool. All right.
Okay, so we're creating 3 candidates to show our stakeholders which one they like best.
Yeah, exactly. If we go back to this little
Space,
diagram,
neon.
we're gonna do this little dance where we've got a few different options. Now, what we want to do, because we can't just give this person that asked for this change, they can't look at my CSS changes and be like, yeah, that looks good. They need to actually look at this running website to determine if this is something acceptable. So while this is running, let's figure out how we're going to actually do that. I have, as the branch name might suggest, I've Daggerized the guest book. So if I say Dagger functions, we have some functions that can actually manage the dev tools for this app. So I can test it, I can build it, but I can also deploy it. So let's look at the code for that, because we saw some code in some slides earlier. Let's look at some code in our editor. So I've opened my editor for the guest book, and we've got this .dagger directory, and that's where the Dagger code is. So these are all like the dev pipelines that can do all the CI/CD things.
Right alongside the rest of your actual project. Yeah,
exactly.
Yeah, I like
so
that. I like
like
that you
guest
name
book
it
itself.
.dagger in case you want to hide it for VS Code. Like people don't have to mess around. Like I'm the person that figure out the Dagger stuff. I put it a .dagger. VS Code hide this folder. Guys, you don't have to touch it, right?
And you can name it whatever you want. That's the default name, .dagger.
Yep.
But if you have some other preferences or rules within your projects, like
DevOps or something like that. Yep.
Exactly.
Or pipeline.
So here's the test function for this app. And so we saw this similar in the slides, where we've got a function. It takes in our source code, and we use the Dagger client to create a container from Golang. And in that container, we set the directory where we want to do our work, and we mount our source code into it, and we run a command. And then our function returns the output of that command. So pretty basic. We're looking at Go code. Like we talked about before, you can write Dagger in lots of languages. You can write this exact same function in Python. So here's Python. We see the container, and it's going to look like Python code, but it's the same API. So the flow should be easily identifiable, basically. And then TypeScript, same idea. You've got the Dagger clients. You're making containers.
Yeah, using promises. You have async. You have wait.
Exactly. So they're all like
proper classes.
The ergonomics of that language that you're using.
These are integration tests, right? This is where I was saying at the beginning, right, Jeremy, that not usually, but people tend to have in the past like a DevOps folder or an end test E2E folder, we call it in open source, right? A bunch of hack scripts, right, that you just run. In this case, that folder now becomes test integration that can take advantage of using containers to do that test integration, where some people just stop at the unit test level. Like, I'm going to unit test with the whatever environment is I'm in. I'm hoping that whoever is running it set up the environment the way I want it. But in this case, you have control about containers, Golang, 124. Like, this is the stuff that's going to head in production. I have a higher chance of success of this not breaking in production, because I'm going to use the exact same container that I'm using in my laptop. It'll be running on EKS.
Yeah, exactly. 100%. And on top of that, when we run Go test, we're not relying on whatever version of Go and other tools that you've installed on your machine. We're containerizing that for your local testing as well, right? So all of it is you're defining these environments within your code of how the commands get run, not just what the command is. And that's kind of where we replace that from bash scripts, where like, yeah, me as the project maintainer can run the bash scripts to run the end-to-end tests, but I know that I have all these different tools installed. And if you don't have the exact same versions of the tools, it's not going to work for you. So this puts all that in code. Everything's in a container. It's portable, it's repeatable, all the things you want. So that's the test. We can also build our app. So we want to build the production app for the guest book. And this is fairly similar to the existing Docker file in the project. If you look at the Docker file, what happens here, and this is fairly aged. I've updated it for my Dagger code, but it gets the Go code, it does the Go build to get that compiled binary. And then in a Scratch container, it copies in the compiled binary and the static assets. So this is like your standard like multi-stage Docker build.
Yeah, you put
Sets
into
default
shame to a
command
lot of people
ports.
that don't do multi-stage Docker files, Kyle. Like people are
Yeah,
still struggling to multi-file.
exactly.
But the good thing is Dagger has a lot of Git repos with a lot of examples, right? That you can just
Exactly.
use it as a best practice. So this is a best practice in multi-stage to have the lowest risk image at the end with that layer.
Yeah, the main idea with multi-stage is that the tools you need to test and build your app are not the same that you need to run your app in production. And
Yep.
so it's best to have a separate stage where you're doing the build. You get the built assets out of that and put them into a minimal image that you're deploying. So that's exactly what we're doing over in the Dagger code here, where we're saying, okay, here's my Go build. It's from this Golang image. We put our code in it. We set these environment variables for the OS architecture so we can deploy this to my M4 Mac, or we can deploy it to our Intel-based EKS runners that we're using. And once we have that compiled binary, it's just in this variable called go build, which is a type of Dagger container. So we bring in that strong typing back into this where we're saying this thing has to be a container. And from that container, now I can make another container over here, drop in my static assets, and then add this file from my first container, right? So this go build was my build container. In there, I know there's a file called /app main, which is our compiled Go binary. So I put that in this new Scratch container. This is Scratch because there's no from, right? So if you look at the first container, it's container from Golang. The lack of from says this is just an empty box where I've got my static assets, a compiled binary. I've set the port and I've set the entry point. So this is my production container ready to push.
So what you
Yeah.
what you were trying to compare was go back to Dockerfile, right? And this using Go, Python, wherever. I think at this age, we're in 2025, folks. If you're not learning a language, pick anyone like Go, Python, TypeScript. You have to, bring up the bar, right? You have to use a language because not you'll be, behind. But one of the things I wanted to show Kyle to show here is, yeah, Dockerfile has a structure of doing it. But if you have looked to a lot of Docker files in your organization, you will squint and say, like, actually, there's a lot of shell scripting in these Docker files, right? We're in the same boat that we were trying to say before, like Jenkins, Tecton, all these things having a Argo workflow, having a shell script, right, that needs to be maintained. By moving the instructions into Docker file, this also is a shell script that is loosely coupled, right? If you mistype a folder or file name to mean another file, right? Or taking like it would take some time to, and at the end of the day, you're dealing with shell script, like loosely type code here, right? It's still code, it's a language, but to bring it on to the next level is let's use programming language. Then at 2025, now we can take more advantage of these agentic AIs with language servers, right? Because with the language server and the agentic knowing how to really write programs and compile and try, they will have better success dealing with a main.go than a Docker file. That's my 2 cents. I don't know what you've seen in the field. That you're working with developers in the field.
A cool thing to highlight here too is, let's say you're a platform team in charge of a ton of repos with a ton of Docker files, and you want to start using Dagger, but you don't want to rewrite all that stuff on day one, right? What I can do is I know that this source directory, which is the source code for my whole project, there's a Docker file in here. And so instead of rewriting this on day one, I can just say return source dot, and it already predicted it for me, but Docker build, right? And so it can literally just look for a Docker file here and produce a container from that. So you see it returns a Dagger container. If it's at a different path, I can specify the path where that Docker file needs to be. And then as we adopt Dagger across the organization, I can say, actually, we're going to write this in code, because now maybe this whole part
right?
where I've realized all of my Docker files have the same steps where I'm setting the base and I'm setting this. I want to abstract that into some shared code, so we just write it once and reuse it everywhere, right? That's the other benefits of writing code for these pipelines.
You got to the Nirvana point. I wanted you to say it.
Yes.
It's shared code, right? Have
Yes.
that code in Nexus inside your company, Nexus or whatever you use. We have AWS registries with NPM, Python, Maven, right? That becomes code that is a library in your organization that everybody gets the new version, right? They can adopt a version when they want, and you don't have this code and these container files as a DevOps, like large organization, right? Hundreds of repos with Docker files. So like, you know what? We need to refactor our Docker files. Who's up to it, right? Fine.
Exactly.
All those repos, right? And then the person that answers saying like, I can get Agentic AI to write a shell script that iterates over get. Like he already lost like with that initial statement, right? Is sharing a library, right? Doing it like the app team is doing it, right? If you ask, if you bring somebody from the app team or development team next door saying, hey, you guys are writing the Go code, the Python code, the Java code, can you help us for a day? He would say like, why you have these files and code everywhere? Like just put it in a library, share it with everyone.
Yeah, dry it up. Let's go.
Exactly.
Yeah.
And so let's pull this back around, because we're gonna see how we can actually connect all this to
our so we are our agents done. I'm curious.
I'm sure they're done. So we have this next function deployed that actually deploys it. So before we go through the code of this, let's see what the agents came up with. We'll pull them out of the oven and see what we cooked up here. So this one says it's done. It says it's space themed. I don't see a ton of emojis in its output, but we'll see how it did. And this other one with our Miami theme,
Miami Nights,
perfect. It's ready to go. So let's get out a queue, and we'll see what we came up with here. So if I say container use list, we're going to list the environments that we have available within all the different work trees on our machine that are managed by container use. And so we see this first one, they have generated names so that we can read them with our human eyes. And this one is a guest book with a Miami neon theme. And the second one, Generous Sailfish, is our space theme. And if we want to say, okay, what did it actually do in this environment? I can say container use diff, and this is basically like a git diff from my current branch that I'm on right now to that environment. And we can see, okay, it updated the title to Cosmic Guestbook, because of course you have to know that it's cosmic. There we go. I've got some emojis.
We got the emojis.
There we go. We got the
rocket.
We're
all set, and we got a bunch of CSS changes and actually some JavaScript in there too. And hopefully it all works, you know. And so, all right, let's take these two environments and put them out on Kubernetes so we can actually see them, and we'll look at the code that it takes to get them out there. And yeah, let's see how it did. So I'm going to take this environment and I'm going to say container use checkout. And now I'm literally, you can see in my Git helper here that I've actually checked out into that Git work tree. Okay. And so with this, now I can actually go and deploy, and this is doing a Dagger call deploy. We haven't looked at this function yet, but we're about to. And we're passing in a bunch of stuff, all the configurations and credentials needed to actually deploy this current source code state out to Kubernetes. And so we'll run that, and over here, we'll wait for it to finish so we can see the cool output, because this is the fancy Dagger CLI that you love so much, Carlos.
Yep.
So finish, we have some output here that maybe looks like something you've seen before if you've been working with Kubernetes.
That looks like Helm. I think Helm is talking
maybe,
to me.
Yeah, we'll find out. And it also told us, okay, here's your service name.
Nice.
And this is where the deployment is. Let's over here. Let's do the same thing. So we had the growing Airedale. I don't know what that animal is.
I think an Airedale Terrier, like a dog. Pretty sure.
Okay, yeah, perfect.
I'm putting my money on that. We'll see.
And actually, this is the one we did before, so we'll do the other one. See you check out. Generous.
Yeah, we're working with Git trees here, right? I at least myself, I have not had a utility or UI to help me with work Git trees in a way that uses container sandboxes.
Right.
Exactly,
so you get like both going on instead of, I mean, once you get Git work trees, you're already like next level, but then like trying to figure out how to get them in containers and not have to write a bunch of glue yourself. That's what and because we already had a lot of these facilities, right, in Dagger. So we figured, hey, it was a good fit.
Cool. So let's look at this code. So like we saw, it takes in a bunch of stuff, like our kube config, which is passed in as a Dagger secret. And I'll look at how those actually get translated, because you're like, wait, how did I make a Dagger secret from those flags I passed in? So we'll look at those real quick. But we have all these credentials that are needed.
ECR, you're pushing to ECR, which is something that you have to configure in your laptop to be able to allow the container to push to ECR. Yes.
Yeah, I mean, so yeah, well, let's check that out. So we have this code, and like Jeremy mentioned earlier, like all the Dagger code here is actually executed in a sandbox. So how do we give it the credentials for my machine to actually be able to, say, push an image to ECR, right? So I have in this function, first we're going to generate that cool environment name for it, and then we call that build function that we looked at before to give us that production container. And so now with that production container, we want to push this to ECR and then get back the image ref of what we just pushed up, because that's what we want to deploy to Kubernetes, is that image ref. So our first step here, we're deploying the ECR, and this is, again, just Dagger code. We've got the Dagger container, we set some registry auth, and we publish. So let's take a step back here. The registry auth is coming from this ECR password, which is coming from an argument, which was a Dagger secret. So how did we get these secrets, like our ECR password, our AWS credentials, our kube config, into this function as secrets? Let's go back up and look at, once again, at the command we ran. So the AWS creds are coming from our .aws credentials, and we've given it a specific profile that we're using. But this is a file, right? Our .aws/credentials is a file, and so that's one way you can pass a secret into Dagger.
Yeah, and you can have multiple, you can have it, not my laptop ones, right? You do in home directory, but I could have a specific file with credentials.
Exactly. Yeah.
Right?
Any credentials file. And you just have to tell it what profile you're using. But we also pass in that ECR password, and this secret is coming from the output of a command. So we're running AWS ECR get login password. And that gives you like a Docker login password.
Yeah, the token. Yeah.
Exactly. So this is run, when I run this command, it's actually generating that token in real time that I could use within that function. And so this is a command. With secrets, you can also pass in environment variables, or you could even configure it to hook up to like 1Password. If I have my secrets in 1Password, I can use this protocol to save my secrets over in 1Password, fetch it from there. So there's all different ways to get credentials into Dagger without just typing sensitive things into your command line, right?
Yep.
Cool. So we've got that deployed. We're looking at the code. So we've pushed up to ECR. How do we get this image now into a running app in Kubernetes? Well,
for dev testing, for like showing someone the two versions, right?
Yeah, exactly. So we're going back to that diagram. We've got these things out there, these green, red, yellow. We want to show these like dev previews to someone to say, what should we actually merge into the app, or what should we iterate on? So we want some dev previews out there to link people to. So the first thing I do is basically get a Kubernetes client in my Dagger pipeline. And so I did this dag.kubectl. Now this is not a built-in part of Dagger. This is a Dagger module that I've installed. So if I look at...
like an extension?
Exactly. So if I look at my dependencies for my Dagger JSON, we see, okay, there's this module called kubectl out here on GitHub somewhere. If we go over to the Daggerverse, which is like this public index of tons of Dagger modules out there, we see like Helm, Java, K3s, like tons
of open source and free,
all
or
these
paid?
Are open source, all on GitHub. So this page is just an index. When I fetch it, I'm just pulling it from GitHub.
Yeah, in a corporation, usually you would like find the open source repo, read the license, bring it in-house, do code scanning, right, and host it, like I mentioned, next to
if you've got
credentials.
Yeah, if you have private repos, you can also have your own little internal index of these based on private repos.
Yeah,
so I grabbed this kubectl.
So it's always to highlight those type of things, right? There's always people like in the learning phase, right? They will use these things from from GitHub directly, and they fetch directly. Wait, what about if GitHub is down for a day? Like, I don't know. You cannot ship. So it's for everything. It's for sandbox, for security, and that you're following the right license. But it's helpful that Dagger is providing this as a registry. People can contribute or make aware that I have some modules.
Exactly.
Yep. And as Kyle was saying, like if you do want to manage as a platform team those internal modules that you keep internal, there's also in Dagger Cloud, there's a facility for that too.
And then
so
you can share for the team. Yeah,
you can get all your open telemetry of all the runs that you're doing here and to do debugging and such, but you can also manage all of those internal modules like this and see who's using what in the org and, figure out if you're going to upgrade something, who's affected, all that sort of thing.
Cool.
Exactly. And it has like nice docs so that across the team we can see how to actually use it.
Yeah. So you answered the first question usually when somebody is going to ask you like, can Dagger do X? You say, we sure have a module that does X, or we can help you build it, right?
There's tens of thousands of modules on the Daggerverse. And if there's not one out there, I will personally help you make it. Right. But the point is, not all of your code is going to look like this, where you're using the raw Dagger API to construct everything line by line. Likely you're going to be using either public or
your own
private modules to kind of abstract all that logic into these reusable components. So I've got my Kubernetes client, and with that I can actually literally just grab the container from that module and install Helm in it. So that's the first thing I've done, because by default it just has kubectl with the correct configuration to be able to talk to EKS. But since we want to deploy this as a Helm chart, so I can actually ship these dev previews the same way we're shipping to production, I want to ship my Helm chart with this image subbed in, right? So I'm going to install a Helm in this container with their official installer script. And then I'm going to mount my Helm chart directory into that container, and that's just pulled from another argument that was defaulted to the path /guestbook Helm. If we look at this, this is my Helm chart. It's my
Helm chart that in your organization is the standard way we deploy apps. And the same Helm chart should, if you're developing Helm charts in your organization, please have one Helm chart that people can use for dev environments, and the same Helm chart in production. And the only thing that you change is the parameters, like the values file.
Exactly.
With something like Argo CD or GitOps.
And so this is exactly what we're doing here. We're going to change some parameters. We're going to say, okay, here's my Helm chart. I want to Helm install that, but we're going to set the name to this, and this is the name that we made up at the beginning with our pet name generation. And I want to set the guestbook image to this, and this is the one that we just pushed to ECR. And so now those are the only two parameters we changed in our Helm chart to be able to actually deploy each version of our app out there. So let's hop back real quick. Oh, sorry, the last thing. So we installed the Helm chart. We wait for a second for the information to propagate across the new resources in our cluster, and then you would say, let me get the service real quick and get the
so you can get the dynamic generated URL that we give you in EKS for a no-load balancer. Cool.
And so this is this information that we saw output here. We said see the deployment at this URL. And so before we click, I'm going to hold everyone's suspense for one more moment here. I can say cube, I'll get pods, and we can see, okay, here's the two.
Yeah, and usually as a developer, you're given one namespace, so you have to like play around with the names with that one namespace given to you in your sandbox. But that's your namespace for playground, right? Small cluster.
Exactly.
One namespace for you.
And yeah, just a preview of what we would do next is there's a cleanup that can easily get rid of those resources for you afterwards based on that name. Cool. So we've got our resources out there. I can say it'll get services.
One more thing. Like if you have to clean up like these dev environments, right? If you delete the pods and you're using something like Carpenter, the nodes will go away. So the cost that you don't have to when you want to have nodes running around for these environments.
Yes. Yeah, and we just have for like the basic tech demo purposes, we just have one namespace, couple of nodes, everything's running there. They're all happy together. Cool. So let's look at these two, see what it came up with. So this first link, we're gonna click on, and this is almost unusable. Our Miami Nights guest book. I can barely read this headline. It's cool that it came up with that, but it's kind of horrible.
Yeah, I like the digital ocean, the blue, the light blue. Yeah.
Yeah, the color
and the
scheme's
sign
cool.
button is good. Yeah.
The glow is a bit intense. I feel like I'm literally in Miami looking at a neon light at 3 in the morning. Awesome. Well, let's see the other one. Maybe it's
The
better.
space. Yeah, the space would be
Yes.
the space wins.
So we're in space.
That's
Wow,
better. Yeah,
this is cool. I don't
better.
see the our messages, so maybe it broke something. But let's say containers couch failed to submit. Okay, yeah, I suspected this was broken because we don't see our
Yeah, it could be that they
messages
change
here. Oh, if we add it
TypeScript
here,
or something.
yeah, and we can look at that too to figure out why it broke. But on the couch, we'll add it over here,
Yeah,
and
and
there
this
it
is safe
is.
on Redis. So this is a typical Hello World
Exactly.
guestbook.
And because it's a tech demo, we also can see it over here on our original
Oh, cool.
terrible
Yeah,
mustard.
same
It popped
Redis.
up
Yeah,
for us. We can see from mustard, and we can see it over here. So it's all working within our cluster. We have multiple versions out there, and we can link these to people and say, I kind of like the Cosmic Guestbook one, especially because it's got cool emojis, and we can't read the Miami one at all, but we just have to fix it, right? So now we can see list and get into that space one and figure out why we can get back
yeah.
into
Start
queue and say
interacting
you
with
broke
the
the
agent, right?
JavaScript. Yeah,
Interacting with the Amazon queue and say like, hey, I'm getting it's not connecting to Redis. Help me the troubleshoot it, and Amazon queue will look at the code like, I see what I did, and I fix it. But the good thing is, in your laptop, you have different versions. And I was kind of joking before about the Git stash, right, and Git pub,
right.
because that's where like some developers struggle, right? Try to
Yeah.
like, oh, I have the agent, I need to run the agent in a safe way, so I'm going to use container use, but then it will modify files in the current directory, but I'm in the middle of something, so I need to stash this version and run the other one. So if I want to do something different, like, well, I need to save that one and run another queue agent, right, and then do the changes on that one. Like it gets messy in terms of Git. Is that something it's not your day job? The day job is right the Go code or the TypeScript, right?
Exactly. And I kind of mentioned like this flow earlier of like, I am working on some super technical problem in the foreground that I don't trust an agent to do because there's just too much context involved. But I have this huge backlog of like more simple tasks that agents are perfectly capable of. I should be just deploying agents in different terminal windows, solving those, and to avoid interrupting me with the work I'm doing, have them in their own work trees doing their own work, and so we can actually, use all the resources of our machines and all these agents to solve all this work without needing me to babysit them along
In a
the
safe
way.
way, right? That container
Exactly, in a
uses in a
safe
safe
way.
way. Yeah.
Yeah.
And this is the cleanup function. So I think that's for the demo today. Let me bring back the
Yeah.
closing slides. Let's see, move here. So yeah, Jeremy, like tell us where we can find more information about Dagger and close us out.
Yeah, absolutely. Yeah. So anybody who's on your smartphone, just go ahead and point that at the QR code, and you'll join us, Kyle and myself, and Carlos, when you're there over in the Dagger Discord. The community is huge and very active. People are always popping in with questions, and we're helping them to build all sorts of cool stuff. There's a container use in a dedicated space channel within the Discord. There's also ones that have to do with things around AWS and EKS and Kubernetes in general. So like whatever you're into, you'll probably find a channel in there and lots of like-minded people trying to solve similar problems. So come join us for sure. If you want to get hands-on right away, like we do, that we learn best trying things hands-on, definitely go to the docs.dagger.io, and there's quick starts there that'll get you going with Dagger and also get you hands-on with Dagger and agents as you're starting to think about how to like navigate this new agentic CI thing. And then container use itself, since it's a separate open source project, you can go to the GitHub, but there's also a really nice containeruse.com where all the docs are hosted, and you can find instructions for setting things up with Amazon Q or with Kiro or with whatever agent that you're using either in your IDE or on the CLI. So yeah, definitely come join us, play with it, tell us what you think, and can't wait to see what you guys build.
Yeah, and Kyle pushed this code. If you want to show this to your organization, right, like show them a demo of like what you saw today about Dagger, and it could be your own app. take a look on this example that uses Amazon Q with EKS and Dagger and computer use, like the end-to-end. I think some people will be impressed, and then show them like, this is how we do it today with shell scripts. This is how we could be doing it with Dagger and container use in a safe way, and get those apps and prototypes like quickly evaluated, right? Get it into dev, and then push the code that it can go to production with a proper GitOps deployment. So thank you so much, Jeremy and Kyle. I knew people, I think I saw you on LinkedIn showcasing container use and agentic stuff. So I reached out in LinkedIn to give us a demo of this stuff. So I'm glad that we were able to do it. And folks, follow the YouTube channel for our next live stream, and join the Dagger community, and I'll keep in touch. See you, folks.
Thanks for having us. See you.
Yeah, thanks so much.
Bye.